Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Chloe. Hi, Chloe. Tell us a few words about yourself and about the tool you want to show us.
Hi there. Yeah, very excited to be on the open source spotlight today. And thank you so much for the invitation. My name is Chloe. I'm very excited to share with you today the open source project that I've been working on for the past year and a year and a half. It's called Ibis. It's a portable data frames library. It's a Python library. And I have been primarily contributing to the streaming sides of this project and driving a lot of visions around the streaming backend development, and specifically taking Ibis origin from a batch-oriented library into the streaming world. So that's been a lot of very exciting developments on that front. And I'm very excited to share with you what Ibis does today.
Well, what does it actually mean, portable data frame library?
Yeah, no, that's a really good question. So on a very high level, it decouples the execution of specific transformations, data transformations, data queries with the writing of the logic itself, which means that you can take the same transformation logic, you can take the same IBIS code and run it on different backends. And that execution process is completely decoupled from the definition.
So it's like we have SQL and we have different engines that stick to the standard, and we can write some transformation logic in SQL and then execute it in Postgres, in ClickHouse, in BigQuery, in whatever whatever database, right? And here, I guess it's something similar, but instead of database, I would have pandas, polars, right? Like things like that.
Yeah, exactly. So it does go a little beyond just the databases, and we also have like engines and in the in-memory databases or in-memory libraries like pandas, polars, other things. And it also allows you to actually execute SQL. So you can think of it as a
Mhm.
higher level abstraction over the entire spectrum with SQL in mind as well. And SQL was created as a standard. However, unfortunately, because different databases have different the intricacies
Neighbors,
and
right?
differences, you can actually execute the same SQL across
Yeah.
different databases, and that's a big headache that people face. And that's part of the problem that we try to solve
Mhm.
with Ibis.
Yeah. So I'm very excited about the demo.
Cool. Okay, so I have this demo running in a code space right now, and it's honestly a pretty simple setup, but I just set up some of the infrastructure pieces, specifically installing DuckDB and installing Postgres, and then setting up a DuckDB to Postgres connection in such a way that when we load data into DuckDB, actually also loads data into Postgres. And this just simplifies some of the backend infrastructure that we have to deal with in the future. And I think for companies, a lot of this is probably already set up by your infrastructure platform engineers. And for the purpose of this demo, we're looking at doing some data transformation, dealing with this data set from a data engineer perspective. And imagine that you might have actually seen this data set before, the IMDB data set that people may be familiar with. So for this data set, we're going to deal with a couple of different tables, and we're going to manipulate the tables, join them together, create some meaningful features, and then see how all of that can be done in a way that allows you to decouple the execution from the writing of the logic. So the first step here is that we are going to just load the tables, load the data that we have in this code space into the databases. And this is just for the setup. So you create two tables here. We're going to deal with two separate tables for the purpose of this demo, and you will see this very quickly. Okay, perfect. That is done. Now we're going to import Ibis. So we import everything from the library. And here we're going to initiate a DuckDB connection through Ibis. So with all the backends, you can write it in a single line of code. And sometimes you may need to pass different perimeters, but here DuckDB is pretty simple. This just gives you a default connection. And you're actually going to read these Parquet files into this DuckDB connection that we initiate. And you can see that finished in 0.4 seconds, which was really quickly. And what this does is that it loads it's going to load and execute depending on the mode. It's going to load or execute lazily for the most part, but sometimes you can choose to go through an interactive mode, which you will see very shortly. So now you can see that there are two tables in this DuckDB connection. One is IMDB title basics, the other one is rating. So as you will see in a short second, so this actually is going to give you an abstraction of the table that we are connecting to underneath the hood in the DuckDB database. So you have this table and you can actually get all the information about the schema of this table. It doesn't give you just from calling this, it doesn't give you any data. It doesn't actually execute anything. It just gives you a high level view over what type of data you have here. And this allows you to interact and manipulate the data without worrying about specifically is underneath the hood. And this, as you will see in a second, is how it allows you to decouple execution from writing of the query. So this, the other table is a basics table, and this one is a little more involved. It has a few more columns, but it just has a lot of basic information about each of the movies. And you can see that the common factor denominator here is a tcons column, which is sort of a unique identifier for the movies that we're going to see. So Ibis works with a lot of in-memory formats like we have mentioned before, for example, pandas. So you can actually just take this table and directly convert it into a pandas data frame. And this also executes really, really quickly. And we're going to just take the top 10 rows. Both of these tables are actually quite large. So for the purpose of a lot of this demo, we're going to do limit on a lot of the queries that we're going to execute. And as you can see, this just gives you the top 10 rows. You can also get PyArrow, you can also get polars if you have polars installed. And all of these just executes very quickly. And this just gives you back sort of a representation of what you're looking at underneath the hood. And now we're going to actually start doing some cleaning, which is a lot of what a data engineer's day-to-day job looks like. So we're going to, first of all, turn this interactive mode. And what this does is that it's going to execute a query to give you a preview of the results so that you don't have to waste time executing the entire query if you know that, oh, I'm just playing around, experimenting with different features. I just want to see what a preview of the output looks like. So by default, this is going to give you a limit of the top 10 results, but you can actually also set that up and change the number of rows you want displayed. So here we're just going to go with the top 10. And we're going to do some renaming. So we give you some of these really nice out-of-the-box methods that people typically want to have in their toolbox. So here you're just renaming all the columns in snake case format. And now you can actually see, so this gives you in the interactive mode, the top 10 outputs, and you can see that the columns are renamed. And this is just a preview of the output. So far so good. And if you want to see the
I want to
sequel,
comment, this is so amazing, like this Siri renaming, because like I don't know how much time I spent on doing this, like from camel case to snake case. It's like
yeah. So we try to we try to create abstractions for users in a very user-friendly way so that you can just leverage a lot of these functionalities without having to rewrite the same thing every time, because it's, what probably data engineers are spending, 60-70% of their time
yeah,
on.
exactly.
And it's, honestly kind of annoying sometimes. And you can actually see the SQL as well if you want to just take that SQL and run. And this does work for all of the SQL queries, all of the queries that we allow you to execute. So if you have your infrastructure set up in such a way that you just want to use Ibis to generate SQL and plug it into your existing infrastructure, then this happens very, very easily as well. You can write an Ibis query, and then you can convert that into SQL. And the more fun part is that you can actually transpile that into different dialects as well. And this essentially allows you to write the same code for all of your databases, all of your query engines, and execute it on any single one of them. And you can imagine that that's very helpful for, companies that are going to evolve their architecture over time. You may start with Postgres, SQLite, you may want to change into a different database. You may adopt Spark or Flink for real-time use cases in the future. And this allows you to write the same code. And you're not going to spend, 6 months, a year just rewriting your entire code base in that transition process, which is a lot of what companies are doing today. And now this is a very simple example, and you will see more complicated ones in the future. And another very fun functionality that you can use through Ibis is the fact that you can also write a SQL query directly and then execute it using the Ibis connection. And where this gets useful is you can see that. So I'm just going to do an example. So 2pandas executes the entire query, and this actually gives you back, a million rows of results. This happened really quickly, right? And this is all happening in the DuckDB backend. But after the execution, it just converts it back into an in-memory pandas data frame. So a lot of what this is doing is that it's executing, and then when you're so conversely, if you want to see an interactive format, you would just get a preview of these results, like we mentioned before, and this allows you to prototype very quickly, so you don't have to, worry about if things are going to execute or not, and this saves up so much time for the data engineer. And the fun part is that you can actually intersperse SQL with Ibis code. So if you're coming to Ibis today and you already have a big chunk of your code base, a lot of your data pipelines written in SQL, you can actually write SQL as is and then combine your future pipelines with Ibis code. So here, this is a pretty simple example, but you can imagine that this can extend for more complicated ones as well. But what I'm doing here is simply I'm casting this column as a varchar column, and I'm just adding some characters at the end. But you can basically piece puzzles together, and this also allows you to reuse the same code again and again throughout different transformation pipelines, different data pipelines you're maintaining. So this is one of my favorite features of Ibis as well. And you can do group by. So a lot of the Ibis API is inspired by there are some similarities, I guess you can compare to pandas. It's also partially inspired by dplyr. So there are a lot of things, a lot of APIs that you may see are a little familiar, but Ibis was actually originally created by Wes McKinney, who was the person who wrote pandas. And Ibis was supposed to resolve a lot of the challenges that pandas wasn't able to solve. For example, the fact that it doesn't scale very well. So Ibis is supposed to take what pandas was and then make it better. And you will see a lot of improvements to different APIs in different ways. And I will also talk about another one of my favorite things in Ibis in a short second. So now suppose that we want to do analysis of the top 10 best movies by rating. So we have two different tables here. We're going to have to do some data cleaning, and then we're going to have to join them together to actually get the movie titles with the ratings in the same table. So here, and this is very representative of what someone like may actually be doing in their day-to-day data engineering job or machine learning engineering job. You're cleaning the data, you're joining different tables, and then you're getting some kind of feature. So here we're taking the same basics table, we're using some predicates to basically get rid of discard adult movies, and we only want to select movies with a movie type. We only want to select the rows with a movie type. So here, we also want to only select the two columns that are useful to us in this analysis. So now you can see this again gives you a preview of the results. You can see that I now end up with two columns, and you can see that it's only filtering for the ones that we specified for. And now we're ready to do this join. So we can join this using the tconst column. That's the common denominator across these two tables. And now it gives you actually the tconst with the title, with the rating in the same row. So this gives you a wider table. And now we're able to order by average ratings. So this is one of my favorite features, which is this underscore, which allows you to not refer to specific tables, but instead you can just sort of, it's like a catch-all expression where you can just refer to, whatever comes before that. And this means that a lot of times in SQL, you're chaining things together. So you're writing longer and longer expressions with each of the chains. But because of this, it will automatically refer to whatever comes out from the query before that, which allows you to chain very, very long pipelines, steps together into pipelines without having to build expressions longer and longer. So as you can see here, this is going to give you the join results and then order by the average rating in descending order. And then we'll also see that here there are a lot of movies with very, very few numbers of votes. So we'll actually want to discard a lot of these movies because we feel like these votes are not indicative of how these movies actually are. So we want to filter for only the titles with more than 1 million votes. So here we're doing that. And then as you can see here, now you end up with only the titles with more than 1 million votes. So this all happened very quickly. And as you remember, so far we have only been previewing the results. And now we feel like we're ready to sort of deploying this or ready to actually set up a production pipeline with this. Then you can actually turn off the interactive mode. And you can see here, so when you turn off the interactive mode and you call this specific variable, it gives you a intermediate representation of what the underlying representation looks like. And I think this is very, very powerful because you can also see this in a graph, and Ibis is doing all this heavy lifting for you inside of the library. So you can see that this actually builds a very, very complicated query that goes off my screen. But you have a table, and then you can actually examine the details of how this is being done. And this is all, just relational algebra. But that's the part of things that people don't want to interact with in their day-to-day process. And Ibis is parsing all the queries for you, building these relational algebra trees, and then executing them across different backends. So now we're ready to actually execute this query. So when you call two pandas, even though we're limiting it to 10 rows, I can actually take this off. And this actually executes the query as opposed to just taking a preview, giving you a preview. So you can actually take this off as well. I think that's going to, so that gives you a total of 69 rows. And that all becomes, so that gives you back an in-memory data frame that you can do whatever with down the road. And you can also convert it into different formats if you have further processes down the road. And the next part is where this can be very powerful is that a lot of times companies have different databases set up for different teams or for different processes. A lot of times, on day one, you start with Postgres or SQLite. Maybe there's legacy reasons that you end up maintaining multiple databases or multiple data pipelines across different engines and databases. And now you're actually able to execute the same expression directly in a different database. So you don't have to rewrite any of that code. Here, you just initiate a Postgres connection. And as I mentioned before, the Postgres connection already has the tables preloaded via the DuckDB connection. And you can, so this is the variable that we have defined before, and you can directly execute that on Postgres. It takes slightly longer, but it gives you back the same results. And what I have been working on, so that's the end of this demo, but what I have been working on is to introduce streaming support into Ibis as well, so that now it's not just across databases. Now you can also execute it across batch and streaming pipelines. And so all of these backends are the backends that we support. We support over 20 plus backends right now. And as you can imagine, this really reduces the amount of technical overhead you would have with maintaining different pipelines. And we really would love for everyone to try out Ibis and let us know what you think.
Yeah, that's amazing. Like it's so simple and straightforward. So as I understood, the main users of Ibis are data engineers or data folks who work on ETLs, right? Who work on transforming data. So in this example, what you did was you had two databases with exact same data. You had DuckDB and Postgres. But what if I want to execute some transformation on DuckDB and then write the results to Postgres? How easy would it be to implement it here?
Yeah, no, that's a great question. So that's actually something that we're working on right now currently. We have seen quite a few people request something like that. So being able to execute queries across different databases. So that's a functionality that we're looking to support soon.
So right now, I use it as execution engine. So we saw this execution plan, this relational algebra, and then at the end I get the result like a data frame, right? This is what I get at the end.
Yeah.
Okay.
So basically, for IBIS execution, it assumes that you already have the data loaded in your databases. We
Yes.
don't actually deal with where the data comes from. So it assumes that you already have your production data somewhere in your database, and then it does all the data transformation for you. And then at the end, so what I showed here was primarily turning into a pandas data frame. But I think a lot of times you're probably not going to do that, especially if your data queries are very large. You'll probably turn it into something else, and we support a bunch of other other exporting methods as well, like arrow or like
Okay.
polars, and there's a bunch of experimental methods that we have.
I see.
Yeah.
And we saw the demo for the batch part. If somebody wants to learn more about the streaming part that that you work on, how can they learn more about this? Where they can find the information?
Yeah, great question. So let me go ahead and share. So this is where all the documentation is. It's just ibis-project.org. And then here you can actually see information about all the backends that we support. So for streaming capability right now, we have Flink support, we have support for Rising Wave, which is another streaming database. And then we are launching support for Spark Streaming right now. And there is an example with Flink right here. So this actually goes through a fraud detection example, and there is a little more setup with some of the infrastructure, just because in order to run streaming pipelines, you have to set up Kafka, you have to set us a sync as well. So there is a little more infrastructure setup, but we basically wrap all of that in a Docker containers, and then you can just connect to all of that and then do similar things with uh, with the pipelines that you saw earlier. And the primary things that we try to demonstrate here was window aggregations, just because that is a huge part of a huge portion of the transformations that you deal with in a streaming use case, because you don't want to be doing aggregations globally. So that is what we predominantly try to emphasize here.
And can you show us how to give Ibis a star?
Yes, of course. So all of this code is open source, and this is our website, or this is our GitHub
It's
code.
ibis minus project/ibis, right?
Yes.
Okay. So this is where all of you should go and
Yeah.
press the star button. Okay.
Yeah.
And since we are already on that page, I see you have like 243 issues. So if somebody wants to help and perhaps take one of these issues, like how can they do this? Or is it the right way of doing this? Like if somebody wants to contribute, what's the approach they should take?
Yeah. So we love new contributors. We have a lot of contributors. I think we're at like 100 something right now. So a lot of people from the community who started using Ibis are contributing back in different ways. So you can be as simple as updating docs, there is a typo somewhere, and all these. If you feel quite confident about just updating something, then you can just go ahead and start a pull request. And we try to review these within a week. So we have triage twice a week. So we try to get to issues within a week's period of time, if not sooner. And if you want to look through the list of existing issues and take one of those, I would suggest commenting on the issue to, especially if the issue is a little more involved. So we do have a tag for good first issue if this is your first time contributing. Okay, I don't remember what it's called. Let's see. I think there is a good first issue. I can't find it right now.
You probably have a community where people can ask for, hey,
Yeah.
like I want to contribute to Ibis. Where should I start?
Yeah. So I think there are some oh, sorry, it's onboarding. So onboarding issues are the ones that are supposed to be quite easy to tackle. But we have had a few onboarding issues that ended up turning to rabbit holes. So when you're uncertain, when you have some doubts, do feel free to comment on these issues, or usually quite fast in response. And if not, just ping us. And we do have a community on Zulip as well. So that's also where you can ask questions and get people to respond. And if you have sort of a high level idea of how you want to solve the problem, then feel free to write down your approach. And then I think someone would be happy to take a look at that as well.
Did you say you have a community on what? Tulip?
Zulip, yes. So
That's
this is,
something new. Like usually we have a community on Discord, we have a community on Slack, or like GitHub discussions or how it's called. But like this thing is something
yeah.
new.
Yeah, so not a lot of communities use Zulip, but I think we chose
How do you call it?
Zulip, ZU.
Okay.
So we chose Zulip for a few different reasons. So one is that it groups things by topic. So it's very different from Slack in the way that it's set up. And there are like a lot of different channels. I think it's maybe a little more similar to Discord. And you can like follow different threads. And I think we generally get to these conversations pretty quickly. So you can see like what people are saying. And there's quite a bit of conversation going on in Zulip as well.
Mhm. Okay. And what are your middle term, maybe short term plans for Ibis? What are the next features you want to add?
Yeah. There are a lot of very exciting things that we're doing right now. So one of them is the cross backend table creation that we have talked about, and we're working on. So we technically introduced Spark streaming in the last quarter, and we're working on expanding streaming functionalities and making better batch stream unification abstractions. So if you're in that space, definitely check out the new APIs and let us know what you think. And we're adding a bunch of experimental methods to export to different formats and import from different sources, so on and so forth. So there's a lot of work we're doing on that front. And I think we're right now on version on release 9.1 or 9.2, at a point where we're trying to reach a stable API and not have too many changes over time. So that's also something we're actively working on. And yeah, I think definitely follow we have a blog as well on our website where we're constantly releasing different projects or different ways of using Ibis. So there's another thing that's kind of cool to look at is the fact that we actually built an analytics app for Ibis using Ibis. And this is what it looks like. So actually all of this, all of the analysis here were done using Ibis. And I think you can actually find this code all open source somewhere, and which I think is pretty interesting. And we're encouraging, if you are using Ibis in some way, we are encouraging you to, write a blog post or tell us about it. And we would love to hear about what your use cases look like. Yeah.
Okay, maybe last question. Do you have any advice to anyone who is watching this?
Advice in general or
Life advice or IBIS advice or whatever.
life advice? Oh, that's a difficult one. I do think that from my perspective of, I guess, doing streaming, I think real time is something that, even so I came from a data science background, and I didn't think that that was something that I was going to get into. But I think more and more so you see this intersection, or there's more of an interaction between the machine learning engineers and the platform engineers. And actually, historically, these groups of people, these teams of people are quite separate. They talk very different languages. And we have seen that when they come closer to each other, when they work together, they're building amazing things. And there were a lot of challenges with translating, features, deploying things into production that you're just not able to do as well without that interaction. So I guess I would encourage people to learn a little more about things that you may not feel very comfortable learning, and maybe that will give you like new ideas and make new connections that you didn't think would be possible. So be open-minded, I guess, is the
Step
takeaway.
out of your comfort zone and try streaming
Yes.
instead of watch. Okay.
Yes.
Okay. Thanks a lot, Chloe. Amazing demo. We all learned something new today. And yeah, so thanks a lot.
Yeah, thank you so much for hosting. Really appreciate it.
And for everyone who is watching, please do not forget to give Ibis a star to support them. So thanks a lot.